Now our absolute value inequalities we have two cases of that. Our first case is where we got the absolute value of something is less than something else. It really is as vague as what I just said. You can have anything in there. We're going to see some oddball cases that we'll talk about though. If it's in that form, then we rewrite it in this manner. Negative q is less than p is less than positive q. Case 2 is where you have the absolute value of something is greater than something else. Then you got p is less than negative q, and there's no or here. P is greater than positive q. Now that or does not mean you can pick one or the other. That entire thing is your formula when working these problems. So let's take a look at this problem. That the absolute value of 6x minus 1 is less than 13. Of course, it's an absolute value inequality because it's got an inequality symbol and it's got an absolute value. The forms here have to have the absolute value by itself on the left side. Nothing from it, nothing after it, simply absolute value of something, which is what we have. So what's inside our absolute value will be our P, and the other side will be our Q. Now, since this is a less than, then we want to use the less than formula. So case 1. So our formula says we're going to rewrite it as negative Q is less than P is less than positive Q. I'm going to plug 13 in everywhere I have a Q, and everywhere I have a P, I'll plug in 6x minus 1. Now after I do that on this problem, then it becomes a three-sided compound inequality like we looked at last time. We want to get rid of parentheses, we don't have any. Get rid of fractions, don't have any. We wanted to take this number over to the other two sides or add 1 to all three sides, however you want to think of it. Negative 13 plus 1 is negative 12. 13 plus 1 is 14. Then our last step is to divide all three sides by the number in front of your x. So we'll divide all three sides by 6. Gives us negative 2 is less than x is less than 14 over 6 reduces to 7/3. Now that's our form. To show you the different notations in graphs, set build on notation, that's one where you put your curly braces, x with a vertical line, and whatever your form was. Your interval notation, since it's between two numbers, then you're going to put negative 2 comma 7/3. Now, since both of these are less thans, specifically it doesn't have a line underneath. It doesn't have a line underneath, that's when you put parentheses. And then our graph, parentheses on negative 2, parentheses on negative 2, parentheses on 7/3, parentheses on 7/3. And you shade whichever way they're opening. They're both opening inwards, so I shade inside. And that'd be our graph. Okay, let's take a look at number 11. I usually show two normal ones and I talk about the oddball cases. So absolute value of 7x plus 2 is greater than or equal to 19. Now, I don't have a greater than or equal to form. It's implied that if you have a greater than here, if you have a line underneath, greater than or equal to, you just simply put a line underneath here, and you put a line underneath all the inequalities. So that's what changes them. Now, the absolute value has to be by itself on the left side, which it is. So what's inside is our P, and the other side is our Q. This is obviously the greater than case, so it's case 2. So that says, and we're going to plug that into P is less than or equal to negative Q. There's an OR here, and P is greater than or equal to positive Q. Again, that OR does not mean you can choose one or the other. Most popular mistake people make on tests is they will just plug it into one of them. And if it's, well, that's what OR means. You can choose one or the other, but not in this case. So I'm going to plug in 7x plus 2 everywhere I have a P. I'll plug in 19 everywhere I have a Q. So I got 7x plus 2 is less than or equal to negative 19. Here's an OR. 7x plus 2 is greater than or equal to positive 19. Now these are just regular linear inequalities, so I'm going to solve each one of them separately. So take 2, move it over. That becomes a negative 2. Negative 19, negative 2 is negative 21. Divide both sides by 7, and we got x is less than or equal to negative 3. On this one, I'll take the 2 over. Comes a negative 2. 19 minus 2 is 17, and divide both sides by 7. Then we get x is greater than or equal to 17 over 7. And that would be our answer. If I were to graph it, we saw the OR last time. Remember, x is less than or equal to negative 3. Would look like that. X is greater than or equal to 17 sevenths. Would look like this. Now our answer with an OR is where everything is shaded. So where you see any shading, that's your answer. Now, if you're wondering how is this written in interval notation, this is negative infinity to negative 3, bracket on negative 3. Infinities always have parentheses. This one is bracket on the 17 sevenths. Goes to positive infinity. Again, infinities always have parentheses. And you replace the OR with union. Set builder, we would just put our curly braces here and X with a vertical line, and then that right there. questions on those two examples? Yes. Now, on a test, on a final, I never put a oddball case on there. The oddball cases, there's lots of them though, and we're gonna go over those now. Okay, I'm working a problem down. And I end up with something like this. Remember, absolute value's only purpose in life is to make whatever's inside positive, or it can be equal to 0. So when you're asking when is an absolute value less than a negative number, when is that? Never. That's a no solution. So if you're working a problem down, you get the absolute value by itself, less than a negative number, then automatically it's a no solution. These indicate steps you can't see. Working a problem down. I get this right here. Now you might think since it's less than a negative number, it's another no solution. But notice that the absolute value is not by itself. To get it by itself, we'd have to divide both sides by -5, because it's always the opposite operation. This is -5 times, so we divide by -5. Whenever you multiply or divide both sides by a negative number, remember you flip your inequality symbol. So less than becomes a greater than. So we'd have this, and it's no longer an oddball case, or what looks like an oddball case. It's one you can actually solve. This would be case 2. So again, make sure the absolute value is by itself before you state anything's an oddball. This one is where you have a negative number here. This one is where you have a less than or equal to 0. Now we've already said that it can't be less than 0, but it can be equal to 0. So in this oddball case, you rewrite this one as x minus 1 is equal to 0. Because it can't be less than 0, but it can be equal to 0. And then your answer is x equal 1. Working problem down. You get the absolute value by itself, and it's greater than a -3. Well, remember, absolute value makes whatever's inside positive, or it can be 0. So when you're asking when is an absolute value greater than a negative number, it's always greater than a negative number. So this would be all real numbers, or you could write negative infinity to positive infinity. And that'd be your answer. Working a problem down, at some point, you end up with something like this. We were trying to solve for x, and x disappeared. Well, you ask yourself, when is 3 less than 2? And that's never. So this is a no solution. Now, on the other hand, if you're working a problem down and your x disappears again, and you end up something like this. And you ask yourself, when is 5 greater than 1? And the answer is always. That's your negative infinity to positive infinity. Working a problem down, you get x is greater than 1, or x is greater than 3. You look at the key. And all the key has is this right here. They appear to drop part of it. Well, if you look at the graph of these, x is greater than 1. That would look like that right there. X is greater than 3 would look like that right there. X is greater than 3 is included with this. So they'll drop the redundant part. On the same lines, you're working a problem down. You get x is greater than 1 or x is less than 3. You think that's your answer? You look at the key, and they tell you the answer is negative infinity, positive infinity. If you ever get weird results and you wonder why, just graph it. It'll probably be obvious then. X is greater than 1. That's going to look like that right there. X is less than 3 will look like that right there. So everything is shaded. That's why it's negative infinity to positive infinity. Now our three-sided form looks like this example. 1 is less than x is less than or equal to 5. The symbols here have to be less thans or less than or equal to. Can't be greater than. Your smaller number is right here. Your larger number is always on this side. Now, if you're working a problem down and you end up with this. Now, this one is not an oddball case. It's just in the wrong form. Because we need a smaller number here, a larger number here. Well, I can flip the entire inequality around, put 2 over here, 6 over here, but I can't lose track of the relationship that exists. Here, the small n opens up toward 2, so when I flip it around, the small n has to open up toward 2. Here, the large end opens up toward the 6. When I flip it around, the large end has to open up toward the 6. And once I do that, it's in the right form. On the other hand, if I end up with this right here, if I try to rewrite this, because, well, first off, smaller numbers on the left side, larger numbers on the right side. That's okay. But these symbols are wrong. The only way I can get those symbols right is by flipping the inequality. They would now be less than. But now my larger number's over here. There's no way you can get it in the correct form. And if you ever run across that in a problem, that means no solution. So lots of oddball cases when you're talking about absolute value inequalities. Questions on anything? Okay, that's into 1.7. Now over on Blackboard, I go into course content. You'll see this My Lab and Mastering Course Home. I didn't look at the Wichita section. I looked here. I think 3 or 4 of you have signed up in it. Make sure you get signed up in my lab and mastering. If I click that, then once you're over here, don't use this grade book to determine what your grade is in the course. Use Blackboard. There's a link that says quizzes and tests. So if I click quizzes and tests, all these say past due. Don't worry about those. I'll change the due date on those once we finish those chapters. The first one you see is chapter 1 test. You get 90 minutes for it. You get 55 attempts. If you need more than that, I can bump that up, but I just put 55 down. I think it allows up to 99. It doesn't allow infinity. The test is due a week from today. It says 11:59, but that's Eastern time, so it's really 10:59 our time. So you shouldn't be waiting until the last minute anyway. Get in, get signed in, start taking this test. Take it early. You can take it multiple times. It takes the highest of your scores. If you wait until next Wednesday, Wednesday evening, you think, well, I'll start early. I start at 8, and take the test. And you go to get signed in, and you can't get signed up for whatever reason. I won't care at that point. You'll get a 0 on the test. You have an entire week to get signed on to it, start taking the test. If you wait until next Wednesday evening, and my math lab is down, I don't care. If Callie's down, I don't care, because you get the entire week to start taking the test. So wait until the last minute is not gonna get any kind of sympathy from me, and you won't be able to take the test. Then I'll give you 0. Any questions on the test and where it's at? Last fall, I had 2 people that it took them till like the 3rd test before they'd even sign on my math lab. So I don't understand that. I assume their parents were paying for their class. Yeah, it's different when you start paying for your own. I think the first time I didn't get, so I went to drop a class late at Wichita State, and I think I paid $700 or $800 for that class. First time you blow $700 or $800, you get in there pretty fast. I decided pretty quick after, if I wasn't interested in the class, I'd get in before that date so I'd get my money back. But yeah, it's interesting. And then I'd have people wait till the last minute, hoping for the best. Sometimes that works for you. And I myself, I work better under pressure. You give me pressure, I'm much more productive and my mind's sharper, I think. But again, internet fails. You can't get on the sites, and so forth. Anyway, enough of the lecture. That's in the same location for the Wichita section. So in theory, there should be no reason why you can't get 100 on every test taken via my math lab. Okay. You'll hear that same lecture on Monday. So, let's see. College algebra. Well, this is getting into chapter 2, and this is section 2.1. This is basics, functions, and their graphs. Now we have something called a function, and this says for every x, there is only one y. Specifically, we'll be thinking about points to begin with, but then we'll extend that. Hard to think of an example of a function in real life. For every car on the road at any given time, there's only one driver. Except for I think they have those driver's ed vehicles that the person, I think, has their own brake. Maybe would they be a driver? I don't know. So you could probably come up with a lot of exceptions. So let's take a look at our first problem. So we got 3, 5, 4, 7, 9, 9. And the question is, determine whether each relation is a function. So it's yes or no question. Well, I'm going to do a mapping on these. I'm going to write down my x values going from smallest to largest, not repeating it. So I got 3, 4, 9. And I'm going to write down my y values going from smallest to largest, not repeating it. So I got 5, 7, and 9. Now this one maps 3 to 5. So I draw a line between them. This one maps 4 to 7, so I draw a line between them. This one maps 9 to 9, so I draw a line between them. Now our definition said for every x there's only one y. And you notice out of each x value there's only one line coming out of each one. That would tell us that yes, this one is a function. Now number 2, we got 5, 3, 5, 4, 6, 3, and 6, 4. Same instructions. Want to determine if it's a function or not. So I'm going to write down all my x values going from smallest to largest, not repeating any. So I got 5, 5, 6, 6, so I only got 5 and 6. For the y values, I want to go from smallest to largest, not repeating any. I got 3, 4, 3, 4, so I got 3 and 4. And then this point here, 5, 3, maps 5 to 3. This one maps 5 to 4. This one maps 6 to 3. This one maps 6 to 4. You notice, out of both of these actually, but out of the 5, there's 2 lines coming out of it. For my definition, for every x there's only one y, that's false. For this 5, there's a 3 and there's a 4. So the answer here would be no. Now the shortcut to that is if your x values repeat, it's not a function. Like if you look at your first problem here, I got 3, 4, 9. The x values didn't repeat, so that's a function. But over number 2, see how we got 5 and 5 right away? Since the x values repeat, I didn't need to do anything. I could have just wrote not a function. How's I look at this one? Is this a function? Yeah. Because remember, we're looking at our x values. My x values don't repeat, do they? I got 2, 3, and 1. Now the y values repeat, but we don't care about the y values. All we're doing is looking at the x's for that shortcut. Or you could do the mapping and draw the lines. And you'll see for each x value, there's only one line coming out of each one. Now that's a pretty hard definition to use if you got anything but points. You know, if I had something that looked like, so this comes back, y to the 5th minus y squared plus, or minus x squared, I guess, plus x minus 3 equals square root of x. And the question is whether it's a function or not. Well, I could plug in x equals 0 and see if it gives me two different y values. I could plug in x equals 1, see if it gives us two different y values. X equals 2, see if it gives us two different y values. I could actually spend the rest of my life plugging in these and still not know the answer, because maybe down here at x equals 10 million, let's see, what's that? One more. Maybe at x equals 10 million is where it fails and it gives us two y values. Just because it worked for the first 9,999,999 values does not mean it will always work. There was a article in one of the news that was talking about that that meteor that's coming close to Earth. Anybody read about that? Yeah, I guess it's around election time. It's going to come close to Earth. Close is like yeah, you read it's just like that's pretty far away. Why are you even reporting on this? Just because meteors miss us, that 10 million times, that they go past doesn't mean they'll always miss us, right? So again, it can come out here and hit us at some point. Okay, actually, let me leave that up there. And we'll come back to that. Now we got an easier definition of a function. And it says, if you have one of the following, it is not a function. If you have y to an even power, it's not a function. If you got the absolute value of y, it's not a function. If you got a plus or minus symbol in front of x of some sort, then it's not a function. If you have x is equal to a number, example, like x is equal to 3, that's not a function. There's actually a more than that in terms of what's not a function. Those are the most popular ones you run across in algebra. There's trig functions that are not trig expressions that are not functions. A lot of those. Could even be piecewise functions that are not functions. Okay. So on this one, it says determine whether each equation defines y as a function of x. We don't want to sit there and try to guess x values and see if any give us two different y values. We use our shortcut. These are the things we cannot have, the bad things. Well, we have y here, but that's y to an odd power. This is y to the first power, so that's okay. No absolute values, no plus or minus symbols. Now you might say, oh, isn't this a plus or minus symbol? No, plus or minus is where you got a plus and then minus right underneath it. And when I say x equals a number, you don't have anything else. So you wouldn't have this 3y. So this doesn't have any bad items, so this is a function. So the answer is yes. And there's no work to show on those, you just write it down. Now here, same question. We're wondering if it's a function. We have x to an even power, but that's okay. We just can't have y to an even power. We have y to the first, that's okay. We just can't have y to an even power. So there's nothing bad here. So the answer here is yes, it's a function. How about this one? Would this be a function? No, because it has y to an even power. You can't have that. So the answer here would be no, it's not a function. There's another one with the y squared. The answer here would be no. Some people get this one wrong. This would be a function. This minus here, again, has nothing to do with that plus or minus symbol. So this doesn't have any bad items. Doesn't have y to an even power, doesn't have the absolute value of y, no plus or minus symbol in front of x of some sort, no x equals a number. So the answer here is yes, it's a function. Here we got y to an odd power, that's okay. We just can't have y to an even power. So that one's a function. This one's okay. Both of them are y to the first power. We just can't have y to an even power. So the answer is yes there, it's a function. And this one's okay. We can have the absolute value of x, we just can't have absolute value of y. So that's a function. Now if I went back to this, is that a function? Yeah. We got y to an odd power, that's okay. We can't have y to an even power. We got x to an even power, but I don't know anything about that. We got the absolute value of x, that's fine. We just can't have absolute value of y. And we got a square root, I don't say anything about radicals over here. So without spending the rest of our life working this problem, this is a function. Now, if you are planning on going on to calculus, there's that simplistic formula I just gave you fails on some problems, but there's other techniques you'll learn in calculus. Now, this next item in this is function notation. And this is what function notation looks like. Function notation has some purposes. Our first purpose is to give it a name. Because if I had something look like this, and if I told you to graph y, well, your question would be which one? There's two y's on the screen. So we give it a name. We don't give them names like Bill and Bob and so forth. We use notation looks like this. That there's no mathematical meaning there. That does not mean f times x. It's purely notation. And how you read that is f of x. Or we get even lazier in math and we just simply say f. This one is read as g of x, or simply g. You get into, if you're going to want to major in business, you'll take classes where you deal with functions, cost function, c of x, profit function, p of x, revenue function, r of x, price function, little p of x. So you have variables that actually have meaning. In this class, we look at functions and we really don't put any meaning to them. That's the next class if you go on in math. Now that's the first purpose. Give it a name. Second purpose is to reduce writing. If you had a problem look like this, evaluate y is equal to 3x minus 1 for y when x is equal to 5. You saw this in earlier classes. You would take your y is equal to 3x minus 1, and you'd plug in 5 for the x. 1, y is equal to 14. And you get y is equal to 14. Instead of writing all those words down, if we have f of x equals 3x minus 1, and we say find f of 5, that says the same thing as all those words. And we work it the same way. To find f of 5, you go and replace your x with 5. 15 minus 1, and we get 14. So again, that's the second purpose of function notation, is a reduced writing. Now the steps for evaluating a function. Step 1, replace all the variables with sets of parentheses. Step 2, plug whatever we are evaluating for into the parentheses. And then step 3 is to simplify. Simplify probably has 100 different meanings in algebra. Okay, so let's take a look at this problem here. G of x is equal to x squared minus 5x minus 2. And we want to find g of negative 3. Now, I'm going through my 3 steps here. Step 1, replace all variables with sets of parentheses. So I'm going to replace the x here with a set of parentheses. I replace the x after the 5 with a set of parentheses. And everything else remains the same. So second power remained, the minus 5, the minus 2. Only thing we did was replace the x's with sets of parentheses. Now whatever is inside the parentheses right here is what I'm referring to when I say whatever we are evaluating for. So whatever we are evaluating for. So on step 2, when it says plug whatever we're evaluating for into the parentheses, whatever you have in the parentheses right here, you put in over here. And then our third step is to simplify. In this case, it might be follow order operations. Do exponents first. Negative 3 squared is 9, and I'll go ahead and do it all in one step. But negative 5 times negative 3 is 15, minus 2. 9 plus 15 is 24, minus 2 is 22. And that'd be our answer. Oops. Okay, minus 5x minus 2. So B. We want to find g of x plus 4. Now, this doesn't have a number inside the parentheses anymore. It has a variable, but that's okay. It's same steps. First step, replace all of our variables with sets of parentheses. Step 2, plug whatever we're evaluating for into those parentheses. So whatever's inside the parentheses here is what we plug inside the parentheses here. And then step 3, simplify. X plus 4 squared is x plus 4 times x plus 4. Here we use a distributive property. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20. I'm going to FOIL those. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. Minus 5x. Negative 20 and negative 2 is negative 22. Combine like terms. 4x plus 4x is 8x. Minus 5x is 3x. And then 16 minus 22 gives us negative 6. And that'd be our answer. Now C says find g of negative x. Again, same idea. You go through the same 3 steps. Step 1, replace all of our variables. We're looking at our original function up here. Replace all of our variables with sets of parentheses. So I got parentheses squared minus 5 times parentheses minus 2. Step 2, plug in whatever we're evaluating for. So whatever's right here, which is negative x, is what we're going to plug in over here. And then step 3 is simplify. Negative x squared. Negative x times negative x gives us a positive x squared. Negative 5 times negative x gives us a positive 5x. And then I'll bring down to minus 2. And that'll be our answer. Now, next problem. We got f of x is equal to x over the absolute value of x. And we want to find f of r squared. After one example, or actually there's 3 examples within one there, but you probably have it. But this presents a unique simplifying technique that you see if you're going on beyond this class. Again, we're evaluating, so it's always the same. You go through and replace your x with sets of parentheses. Everything else remains as is. Whatever we're evaluating for, so whatever's inside this parentheses is what goes in here. So I'll put r squared in there. And then we want to simplify. That parentheses on top isn't doing anything, and those aren't doing anything, so I can drop them. Now, when I square something, for example, if I have negative 1 squared, that gives us a positive 1. If I have 1 squared, that gives us a positive 1. So it appears like whenever you square something, it's always positive. Now remember, absolute value's only purpose in life is to make whatever's inside positive. So those absolute value bars aren't necessary. So you can drop them, and when you do that, r squared divided by r squared gives you 1. And that'd be our answer. Questions on evaluating functions? They give it to us. They're asking us to evaluate for. Now, next topic is the vertical line test. vertical line test says if any vertical line can intersect the graph at two or more places, it is not a function. Any vertical line can intersect the graph at two or more places, not a function. This method works out best if you have the graph given to you. If you're trying to put it into TA3, TA4, if it's not a function, you can't put it into the calculator, so it kind of defeats the idea behind this. Now, if I look at this this problem right here, it says use a vertical line test, identify graphs which y is a function of x. So it's asking whether it's a function or not. Something like this. If I draw a vertical line here, for example, it intersects at two or more places. So the answer is no, it's not a function. Now you might say, well, you can draw it over here and it doesn't intersect two or more places. So why I chose. But the test just says if you can put it anywhere, it intersects two or more places, that causes it to fail. How about this one? Would this be a function? Yeah. I can draw vertical lines. I can draw them all day long, and the most it'll ever intersect is one place. Now this is an oddball one. Yeah, there's one place where I can draw a vertical line that causes me problems. If I draw it right on top of this one, it intersects in an infinite number of places, which is definitely two or more. So this one fails. This is not a function. This is specifically the graph of x equals -2. And I said in my easier definition, I said if you have x is equal to a number, it's not a function. Now, what causes this to curve around like this is where you have y to an even power. So that fails from that standpoint. Now on number 17, we need to take a look at what this represents here. And probably can do it. So if I screw up the slideshow, when I do the slideshow, I usually screw up the sharing here. Let me try it. Oh, that's nice. Now we're trying to find out what this is equal to. That's nicer. Now it's on my screen. That's good. My pen isn't on here. All right. I'll try it another way. You can't see it anymore, can you? That's great. Question is, did I stop my recording even? In these displays, duplicate these displays. Okay. Recording's still going, so that's good. Okay, so try it another way. Okay, so this is what we're trying to find. Trying to find f of 0. So we're trying to find something. I'll put a blank here. We're trying to find this. Whatever number is inside here is your x. This is your y. So we're looking for a point on a graph. Our x is 0. That's 0 comma something. Like this point right here is 3 comma 0. That's not it, is it? This point right here is 2, negative 4. That's not it. It doesn't start with 0. This point right here is 0 comma 4. And that's it, because it starts with 0, doesn't it? Now, all they're wanting for the answer is the 4. So our answer would be 4. Does that make sense on that? What they're doing is they're making a connection between your function notation and the points on a graph. So what would be my answer here? F of 1 is equal to 0? Because the only point to start, remember this is your x, the only point that starts with 1 is this point right here, which is 1, 0. How about here? What would this be equal to? You're looking for the point on your graph where x is the part of the point where x is 2. Y would be 4. So down there. Now in these next problems, they talk about the domain, range, x-intercept, and y-intercept. We kind of talked about x-intercept and y-intercept before, so I won't write down the definition of those again. Remember, the x-intercept was where your graph crosses the x-axis. The y-intercept is where your graph crosses the y-axis. But domain and range. Your domain is your x values where your graph exists. Your range is your y values where your graph exists. In real life, the domain drives the range. So the domain drives the range. I like to eat Chinese food. There's a place in Wichita called Byway. It's on Rock Road. Really good place. You just don't want to go there too late because you probably get shot. They have a lot of gangs that come in. They used to. They would open at 8 or 9 at night, 7, real late, and then they'd stay open to like 3 or 4. They really catered to the drunk crowd. I'd never had any problem. I just always go there at 10. It'd be fine. Good food. There's PF Chang's. Panda Express. I don't really like Panda Express anymore, but it's one I can think of. There's even a fried rice in Wichita. Now, by the way, that'll probably run you $10, let's say. PF Chang's is probably 25. Panda Express, 6, 7, 10, is it? Wow. Guess I haven't been there in a while. Fried rice was $5. I don't know what they made the mystery meat out of there that they can afford $5, but it's actually pretty good. It's kind of a little bit on the greasy side, but good food. Now, I'd like to get PF Chains every time, but I can't afford $25 per meal. Wish I could. So the money in my wallet drives the restaurant choice. So the money would be my domain, and the restaurant choice is the range. Now, we don't have to think about that in this class, but if you're going on to business specifically, oftentimes the challenging part is determining what's your domain and what's your range. Okay, so in this problem, they want us to determine the function's domain. So here, your domain is where your graph exists x value-wise. Now, I really want to think of it in terms of my leftmost point and rightmost point. As this is going down, it's slowly going left. So as it keeps on going down off the screen here, it'll keep slowly going left forever. So it's going to what x value? Negative infinity? Because it's slowly going to left forever. Now this one, as it's going down, it's slowly going to the right. It'll keep slowly going to the right as we go down forever. So it's going to a positive infinity. So my domain is negative infinity, positive infinity. Now my range is my y values where my graph exists. Now this is going down forever, so it's going down to negative infinity. It does have a highest point though. It doesn't go up here. The highest point it goes is right here. And if I come straight over to my y-axis, that's 1. And for numbers, you always put brackets unless you have an open circle, which I think we'll see in the next example. Now for x-intercept, that's where a graph touches or crosses the x-axis, and looks like it crosses a 1 and 3, and I know that's pretty small. And for a y-intercept, looks like crosses at -3 down here. So those would be my answers for that problem. Now in terms of this one, again, our domain is where x values, where our graph exists x value-wise. Now this solid dot here and this open dot here means it ends. It doesn't keep going forever. So this is my leftmost point right here. And if I can come straight down to my x-axis, that's -3. And it's a solid dot, so it's a bracket. Only time you put an open dot is when it's a parenthesis, or only time you put a parenthesis is when it's open dot. Now this is my rightmost point. If I come straight up to my x-axis, that's 0. And it's an open dot, so I'll put a parenthesis there. And that'll be our domain. Again, that's the x values where our graph exists. Now our range is our y values where our graph exists. Our lowest point is right here. If I come straight over my y-axis, that's -3. And it'll be a bracket. It's always a bracket unless there's an open dot. And I specifically put a solid dot here just to really emphasize it. But even if it wasn't there, unless there's an open dot, you wouldn't put parentheses. This is our highest point. And if I come straight over my y-axis, that's 1. And it'll be a bracket because it's a solid. Now, x-intercept is where a graph touches or crosses the x-axis. And this is an estimate, maybe -2.7, -2.8. This one's kind of tricky. What's my y-intercept? You think that, except for the open circle means it doesn't include that point. So it gets closer and closer to it, but never touches the y-axis. So there is none. Won't see that. If you saw that, you're probably a math major. You need to change majors. Questions on that? Okay. Did I save anything? Change it. Now we're going to stop there because I want to give time at the end. So if you're having trouble getting into my math lab, I can address that now. If you don't have any questions, don't have any problems, you go ahead and feel free to take off. And I'll see you Monday, I guess. It's Jeremiah, right? Have you got signed into my math lab yet? Oh, okay, that's fine. I didn't even check the Wichita section this morning, so I was just curious. Oh yeah, on Harry, right? Yeah, down there by the old Wichita Mall. Yeah, that's a good place. Yeah, yeah, that is a good place.